All right, section 4.5, Math 9. It's entitled Using Graphs to Estimate Values. Using graphs to estimate values. We talked a little bit about this, I think, in the very first section. When we looked at what a graph was, we looked at what the information on the graph was. We're going to explore this a little more deeply today. I think this is a bit of a shorter lesson, so that might be good. But anyways, it says, example 1 says, use the graph below to answer the following questions. Okay, so we got a graph of Bobby's family trip. We're on freeze. And this is the title of the graph. Make sure you remember that all of your graphs need to have a title. Okay, and each of your graphs need to have some very important things. For example, they need to have the quantities on each axis. So in this case, it's distance and time. Time is on the x-axis or the independent variable. And distance is on the y-axis or the dependent variable. Also, you need to have units, okay? So distance, you need to have the units for distance. Is it miles? Is it centimeters? It's kilometers. And time, is that seconds, minutes? Nope, it's hours, okay? So these are all characteristics of a graph, very important. You're also going to have a line on the graph, and in this chapter, we're dealing with linear equations only. So any line or a portion of a line that is straight, that all the points line up into a straight line, that's a linear relation, okay, a linear equation. So from this graph, we're going to answer a few of the questions here. So the first question is, how long did it take Bobby's family to travel 320 kilometers? And actually, I think you all have this too. It's in red on the screen, but I think it's in black maybe on your notes in front of you there. But what we do is we try and find a single point on the line, okay, that contains this information, 320 kilometers. Now, over here we have time, hours. Here we have distance in kilometers. So what you're going to want to do is you're going to want to find 320 kilometers. And because I'm going to zoom in here, and they have this outlined already, but why is it this line? Well, because there's 1, 2, 3, 4, 5. Okay, there's 5 spaces between 300 and 400. And so if you take 100 divided by 5, each space is worth 20. So this line right here is 320, okay? Okay. So now what we do is we go straight across. You'll see this red line, and we'll follow that straight across until we get to the actual graph, the actual line. And then we stop. And then what you do is you drop a line straight down.
Mr. Wade Robertson.
You drop the line straight down and see where it intercepts the x-axis, or where the x value is that is associated with this 320. So really what we're looking for is we're looking for the point, okay, on the graph. If you think of it this way, I'm looking for the value that is the x value that goes with 320 as a y value, because here's the y axis here, see? And so it looks like it's 4. Pretty easy, right? You guys okay with that? 4? So it looks like it drops right down to 4 hours here. So how long did it take Bobby's family to travel 320 kilometers? It took, I'll write it here, it took 4 hours. Make sure you put the number and the unit in a some kind of clear sentence form would be really nice, and I just don't have a lot of room to circle that, but that would be your answer. Okay? Any questions about that? I think this is really maybe an easy concept for you, right? You've looked at graphs before, and this is pretty easy. Okay. Now, we talked about these two words coming up. We talked about these, I believe, in the first or second lesson. Interpolation and extrapolation. So who remembers what, well, I guess it's right here. So interpolation, we did define this earlier. It's an estimate of a value that would lie between 2 points, either that's on the graph, 2 points that are on the graph, or 2 points that would be listed in a table of values. So we're estimating values that lie between 2 data points that we would have graphed. And so if one of the data points was, 1 hour and looks like 80 kilometers, and 2 hours, and 160, and 3 hours, and so on, and we didn't have a point for 4, but we had a point for 5, then if we had these points in between there, and we have there, and let's say we just have 3 points and we drew this line, well, finding information in between 2 points that we've graphed would be interpolation. okay? And we discussed that earlier. Inter means in between, okay? Inter, between. Now, how long did it take Bobby's family to travel 640 kilometers? And here's where we have to sort of extend our knowledge a little bit, and we have to try and map out 640. That's beyond the scope of this graph, it looks like, right? So how are we going to do that? How are we going to do that? Well, from the graph, if it's possible, do you have an answer for that? Did you want to suggest something? Do you have your hand up? No? Okay. It looked like you had your hand up there, but you were just stretching. Okay. You're just showing me your pencil? Okay. All right, good. All right, well. Okay, so on the graph, if you can extend the line that's given, right? So remember, there's little arrows on each side, and it might not be reasonable to extend the line this way. And why would this not be reasonable to extend the line this way, guys? What's wrong with the data that would be down in this area down here? Okay, you can't have a negative distance away from something, and you can't have a negative time, so we can't go back in time. Right, so 0, 0 looks like it was going to be our start point. We start recording the time, we start walking or whatever it is, traveling. Okay, so this might not be reasonable, but certainly one of the important pieces of working with graphs is that we can get data that is not necessarily directly measured. We can expand the graph a little bit. And so in this case, what we would do, if you could, is you would extend this with a ruler as best you can. You would extend it up like this, and then you would extend this line up. Now, this has not really allowed for a great graphing situation. Let's see. So 400, I gotta go 1, 2, 3, 4, 5. Here's 500, right? And then, oh boy, I'd have to get my ruler out and be 1, 2, 3, 4, 5. Here's would be approximately 600, but I'm getting really, really far away here, aren't I? 20, 40. So this would be maybe 640. I think that was the question, right? Okay. So 640. Graphically, this is what we would do. We would extend the line, and here's 640. So I would have to go, I'll use my red line here. I would have to go straight across using a ruler and making sure this is really straight best I can. And that's the best I can do by hand. And then what I'd have to do is I'd have to extend this one too, right? I'd have to extend this line too. And so 5, 6, so here's 7, here's 8, here's 9, and I would have to do my best to find out, well, here's the value, and that would be my guess, okay? So this is called extrapolating. Extra is the root for extrapolating. That means going beyond, right? Okay. So what do you think would be a good guess here, just by my rough graph here? So something right around here, what do you think would be a good guess? Anybody? Okay, 8 hours. Well, if I'm looking vertically, here's the vertical line here. I'm going to try and, drop as close to vertical as I can. That's definitely coming between 7 and 8 there. I don't think that's going to be. I don't think 8's a great guess. I don't know if 8's a great guess, just based on what I've been able to draw here. Now, maybe it is close to 8, but it looks like it's between 7 and 8 somewhere. Okay. Now, okay. So, is there a way that we can do this without using the graph? Is there a way we can do this without using the graph? Yes.
If you could see the first question, it's actually half of what the second question is. It's 320, but when you times it by 2, it's 640.
Okay, very good. So in A, that's a good observation. In A, they were asked about 320 kilometers, okay, which was 4 hours. Okay, so extending this graph might not get you a very accurate answer. So some of you said 8 hours. By this graph, it didn't look like it was 8 hours. So this is a little sketchy. And if you use a ruler, maybe you're going to be a little bit more accurate. But this is a good thing to notice. 4 hours was 320. Now, if we started at 0, 0, okay, that's a good idea to think about doubling. If we double 320 to get to 640, we could double 4. You have to just be careful, though. If this line doesn't start at 0, 0, if it was something like this right here, if it was this line right here, then you'd have to be real careful because it wouldn't be exactly double. But because it's at 0, 0, actually, it might work out pretty good. So here's what I'm getting at. Can we figure out what an equation is for this line? Have we done that before? Figure out equations for graphs? Yeah, absolutely we have, right? So why don't we do that? Why don't we go ahead and, okay, so we've got, I'm guessing right here, maybe 7.8. Using this data, we guess maybe approximately 8 or pretty close to 8. So let's see what the equation might say. So if you remember how to do that, let's build a table of values. Let's try and get a table of values here. That's one way you can do this. So the table of values, we have 0, 0. We know that we have, I think I mentioned this before, we have 1 and 80. We have 2 and, what was 2? Was it 160? Looks like 160. And we had 3 and 240. And we had 4 and 320. Okay. So that's going to be enough to help us find out what this equation is. And from a table of values, what we've done before is we've looked at the x values and the y values to see if they both jump consistently. Okay? So this one is, we've written out points that go up by 1 each time. That's awesome. All of these are plus 1. Is there a consistent jump between these values here? What is it? It's plus 80. Yeah, very good. Okay. So, armed with that information, what we did was we said 80 divided by 1, which is just 80, times x gives us equals y. So I'm going to start with that. Y equals 80x. Okay, okay. Now, we have to also check if there needs to be any adjustments made. I always speak in terms of adjustments. So let's pick a point or 2 or 3 and see if there's any adjustment that needs to be made to make an equation that relates x and y. So 80 times 0 is 0. That is correct, but that's not a very good one to base all your equation on. So let's get the next one. 80 times 1 is 80. Any adjustments that need to be made to get 80? Nope. 80 times 2 is 160. 80 times 3 is 240. Okay, so there needs to be no adjustment to this. Awesome. Do you know why also there needs to be no adjustment to this? Because we do have the graph. What's the y-intercept of this graph? What's the y-intercept? Yeah, it's 0. Okay, it's 0. So guess what our b value should be in y equals mx plus b? It should be 0. And notice that it is. All right. Now I'm gonna leave this table of values alone, and I'm gonna now go from the graph, because this is important too. I don't know if we've spent a whole lot of time on this. And again, this is you might not see this dealt with in the book, but again, I want you to be very clear on equations and graphs and information of graphs. So just one more thing here that you should already know about, but if we just look at the graph and forget about the table of values right now, if we look at the graph, we would say I would need to find out what the slope is and what the y-intercept is. And then we could build an equation of y equals mx plus b. So this is what we've studied. We know that b is 0. Awesome. What's the slope? Well, the slope would be calculated by finding out between any two known points what the rise or the difference in the y values between those 2 points would be, divided by the difference in x values. Okay? So slope is rise over run between any 2 points. And when you divide those and simplify it, that's your slope of your line. So it's easy if we go from 0, 0 to 180. That's really easy, isn't it? Because I go up 80 and I go over 1. So the slope is the change in y values divided by the change in x values, which is, in this case, between these 2 points, 80 over 1. So it's 80. Now, if I took any 2 other points that are on the graph, I could do the exact same thing to find the slope. So again, I think that some of you are maybe a little fuzzy on this, so that's why I'm doing this. So if I go from this point to this point, watch this. I have to go from 80 all the way up to, what is that, 240? So 80 to 240, what is that? That's 160, isn't it? Okay, so I have to go up 160 to get to the same level as this second point that I'm going to measure. and then I have to go over 1, 2 units. So what's 160 divided by 2? Yeah. You see how that gets us 80 as well? It's the same number. So any 2 points, the rise divided by the run, or the change in y values of the 2 points divided by change in x values, will give you the slope. So you don't need a table of values if you have the graph, and you can find out an equation. So the slope is 80. So that means that our equation is y equals 80x plus 0, which of course is what we already found. Okay, now back to the question here. Back to the question. How long will it take Bobby's family to drive or to travel 640 kilometers? Well, 640 kilometers would be the y value, so we need to find out what this x value is, right? I'll erase this. And so you could do, this one's pretty easy. You could do like trial and error here, right? You're like, well, what is x value? 80 times what gives me 640? Or the actual algebraic way to do this would be to divide both sides by 80 to get x by itself. And what's 640 divided by 80? It is exactly 8. Oh, so there you go. Well, 8 seems to go with this value of 8 right over here. So the graph that we made was not quite accurate. And that's the risk you run when you extend that graph a little bit. Now, if you use a ruler and you're very careful, you should have, these numbers all should line up pretty well. Okay? So, interpolation, extrapolation, getting information from the graph is the main point here. To double check that information, good idea to figure out, hey, what's that equation, which we spent time on already. Okay. Any questions about number 1? No. All right. Example 2. So the question is kind of starts on this page. Use the graph below to answer the following questions. Okay. So the graph below is right here, this big graph right here. And what's the question? Determine the value of y when x equals -2. Okay, so this is the really easy part of this section, honestly. When x equals -2, we know that the x values are on the horizontal axis. And so what I need to do is I need to find -2 on this x-axis, okay? It's right here. This is where -2 is. And so when x is -2, the y value will be up where the graph is. So we go up to the graph, and this is the point that has an x value of -2, right? And the y value is the value that is this horizontal value here. So we have +2. Thank you. Does everyone see that? So y equals +2 when x equals -2. Because of this, you go over to x -2, you go up to the graph or down to the graph, whatever you may have to do. And then what is the y value of that point on the graph? So this point is -2, 2. See that? Any questions there? We'll get lots of exercise here with this graph, no problem. What is the x value when y equals 5? So when y equals 5, what is the x value? Again, we're looking for the point that has a y value of 5. Or what you can do is simply go to y equals 5 on the y-axis. So here's 5. And then you search left and right. Where's the graph? Well, the graph is over here. So what is the x value that corresponds with this part of the graph? You go all the way down, straight down, and it is looking like that's the number 4. So x equals 4. Any questions about that? Okay. That's pretty easy. What about determine the value of x when y equals 3? When y equals 3, what's the value of x? Well, y equals 3 is right here. How far, where do we have to go to get the graph? Well, nowhere. The graph is right there. So what's the value of x when y equals 3? Yeah, it's 0, see? You drop straight down and you run into x equals 0. Okay, so that's pretty easy, right? That's pretty easy. Any questions about using any information from the graph? No? Okay. So I'll just do number 4 real quick with you here. It says, This graph represents a linear relation. Determine the value for x when y equals 5 is the first one. So again, y equals 5, that's the those are the numbers on the vertical axis. So we go up to 5 on the vertical axis, and then we go over to the graph. And wherever we hit the graph, we then drop a line straight down, and that x value that we run into is going to be the answer. So when y equals 5, x equals what? What's that value? Y equals 5, x equals 6. Yeah, right there. So A, number 1, is x equals 6. Number 2, when y equals negative 1, that's right here, and it looks to be an intercept. So that means that x is 0. Good. When y is negative 2, what is x? Now here's the tricky. We have to go left now. So you see, we have to go left to run into the graph there. So when y is negative 2, x is what? Negative 1. Yeah. And we'll do b as well. So when x is negative 4, notice that we go to negative 4 on the x-axis here. And then the graph is below, so I go down to the graph, and wherever it touches, I can then go back over here, and that's going to be negative 5. You see that? When x is negative 4, y is negative 5. When x is positive 2, y is 1. I go up to 1 there. And when x is positive 5, I go over to positive 5. Then I have to go up where I hit the graph right here, and that's a y value of 4. Easy peasy, right? So most of these questions are just, you just look at the graph and you just find the information. Now what I would like to do though is to take a look at number 8 with you. So 7, okay. I want to do number 8 with you. Number 9 you'll do on your own. I'm going to go over number 8 with you, okay? So word problems are important, okay? Graphs give you information about two quantities that are related to each other. And so they'll ask you, given one quantity, what's the other quantity that's related there with that value? So this one says, this graph shows the price of a new game console, how it changes with time. And you can see right away that the value of the game console is going down over time. Does that make sense? Old versions of things, old technology, maybe it gets cheaper as time goes on, is that right? When they first come out, they're really expensive, and then over time it drops maybe just a little bit, okay? Generally with new things, they go down in value. After a while, this might change. If someone's like, oh, I'm looking for a game console from 20 years ago and no one has one, I really want one, well, that value might go back up then, right? It might be up. But generally, over the first year and a half or two, prices go down for things like this. So estimate the cost of the game console 5 months after release. So this is time in months after release, and so I go over to 5, and you have to be careful with the scaling here. So it looks like each square is 2 months, right? So 2, 4, 6, 8, and so on. So where's 5? Well, 5 is between 4 and 6, so you got to go right in between there. So if you go all the way up, staying right in between those lines, you'll have to make your very best estimate as to what y value this is right here. So that looks to be about, what would you guess? Okay, about, here's 500 and here's 550. I would guess about 550 is perfect, yeah. So about $550. Make sure you include your units, okay? Don't just say 550, $550. And B says, how many months is it until the console costs $500? Well, $500 would be on the y-axis, and we would go over and try our very best to see where it intercepts the graph, and that looks like 10 months, right in between 8 and 12. So how many months till the game console costs $500? 10 months after release would be your answer there. C, estimate the price of the console 1 year after it's released, while 1 year is 12 months. So let's go to 12 months here. Let's go up, and this, that's going to take a little bit of guessing here. It's just under 500, isn't it? So you might say maybe $480 or $485, something like that. Make your very best guess, okay? All right, any questions about number 8 there? You guys are good? All right. All right, so you have the last about 15, 16 minutes of class to work on this assignment. Please go ahead. You might not be asked to write equations for this section, but you obviously have been over the last number of sections. So this one is focusing just on using the graph to either interpolate or information outside the graph extrapolate.